Hi everybody, in this video I'm going to keep going. This is activity 5.4. We're talking about our submission form here. We've done basically all the steps in the first two videos about using the trend line and some things like that. So we've gone through step C, reading through here, how can the trend line of the scatter plot, we'll let you get that from the answer key in the teacher resource guide. Type out the equation of the trend line for your mass volume data. All we mean by that is take this y equals 0.6522x and let's go ahead and type that in here. I want you to use something called the equation editor though. You can get to it pretty simply by coming up here and just clicking insert. I can come over here to symbols and choose equation. So that's one way to do it. And when it does, it'll allow me to type in an equation. I want you to notice though it says the keyboard shortcut is Alt equals. If I hold down the Alt button and hit the equal sign, okay, that also works. And what we want you to type in is y equals 0.6522x. That's all we're looking for here, okay? We're not looking for anything else. That's the equation from the trend line. If we were going to do the same thing, but this time we were going to use it and write it in function notation, it's going to be almost the same thing here. We're just going to do all equals, and this time instead of y, it'll be mv equals 0.6522v. So in other words, instead of writing it y as a function of x, we're saying it's mass as a function of volume. Highlight that real quick, make it red. Now, what is the slope of the trend line, including units? That would be 0.6522 would be the slope. But as far as the units go, we're talking rise over run. Well, the rise was grams, and the run was cubic centimeters. So it's 0.6522 grams in per cubic centimeter. And what that means is for every rise, for every 1 cubic centimeter of volume that we add 0.6522 grams of material of mass. How does this answer compare to your calculated value of density from above? Well, the calculated from the density above, what it really means is compared to the values that you have here. Okay, and we'll notice that it's a little bit different, but it's pretty close to the same. And the differences that you see there have to do with the fact that these are actual boxes we measured. And so, yeah, there's going to be some variability. There's things like glue that you got to take into account. The person that uses more glue is going to add more mass without adding any volume. Things like that, you know, measurement precision error with measurement, things like that. So that's what they want you to talk about with part H. Now, converting the mass indicated by your equation, trend line, to weight density in pounds per inch is not that bad. What we're going to do then is we're going to change. We're going to hit Alt equals, and we're going to type in an equation that helps us calculate and change 0.6522, and that would be pounds, excuse me, that would be grams per. Now watch what happens. I'll hit the slash button and I'm going to hit space. Okay. Now I don't like how this sets up. I'm going to change a little bit. 0.6522. I want it to be on top of the fraction. And what I'm going to start with then here is 0.6522 grams for every 1 cubic centimeter. And every time I hit space, that adjusts in superscripts for me. I'm going to multiply this by a bunch of things. So I'm going to multiply it by some fractions. I'm going to start by hitting the design and the equation tools. I'm going to hit design and hit multiply by. And I'm going to start off by multiplying and changing grams then to something else. Okay, and in this case we want to change it to pounds. So I would need to pull up here my formula sheet, and see, I guess I don't even have that up. I'm gonna go Google it real quick. Formula sheet. Here's one. This will be great. Scroll to page 3. Here are all our measurements here. And see, I don't have one that goes straight from kilograms to pounds or grams to pounds, but I do have this one here that goes kilograms to pounds. So if I can do grams to kilograms and then kilograms to pounds, I should be able to convert this. And by this point in the class, your kids have already done unit 3.2 is on unit conversions. So they should know how to do this. But what we're going to do then is we're going to set up a fraction. On the bottom of the fraction will be grams. On the top of the fraction will be kilograms. We're going to arrow over. We'll worry about the units in just a second, or the actual values. Let's set up another fraction. I'm going to hit the space, or excuse me, a slash and then space, and it sets up a fraction for me. We're going to set up kilograms to be on bottom this time, so it'll cancel out. And we're going to set up pounds to be on this side, on the top. We know from the conversion sheet that 2.205 pounds is the equivalent of 1 kilogram. In fact, I'm going to go ahead and abbreviate that. We know that 1 kilogram is the equivalent of 1,000 grams. So right now, if I just use this factor, this conversion factor, what would happen is I would take 0.6522, I would divide it by 1,000, and then I would multiply by 2.205. That would give me units of pounds per cubic centimeter. That's pretty close, except I don't want to be in cubic centimeters, I want to be in cubic inches. So I need to do one more fraction. And this time, I'm going to type in the following. I know that I have 2.54 centimeters is the equivalent of 1 inch. But the problem is this is cubic centimeters. And so what I'm going to do is I'm going to take this whole fraction, I'm going to put it inside parentheses. So I'm going to come up here, I'm going to go to bracket, I'm going to choose parentheses, I'm going to include that whole thing inside of parentheses, I'm going to cube the whole thing, just the centimeters. So what it's going to do then, in essence, what we're doing is this. We're going to multiply by 2.54. But we're not going to do it once because that would be linear centimeters. We're going to do it 3 separate times, once for every single one of these powers of centimeter. So when I get done, what it's going to look like is this. 0.6522 divided by 1,000 times 2.205 times 2.54 times 2.54 times 2.54. And when I get done with that, I'm going to have a unit that is in pounds. This is the only one that doesn't cancel, and per cubic inch on the bottom. So that's how we're doing that. That's the math behind it. And you're going to do the same thing. It says convert the mass of your box to weight in pounds. And what they're asking for is you're supposed to pick your particular box and do the same exact step here. You can use, if you want to, you can go back and just pick any of the 5 boxes. Pretend like you're one of the 5 people and do it there. Okay. And then it says do the same thing to ounces. So we'll let you go through and kind of work through that. How do I convert to ounces? You can copy paste this, of course, and use this equation as a starting point if you want to. But again, for J and K, just choose one of the boxes. It doesn't matter which one. Hopefully that helps, and you're able to get through at least a little bit of the parts I, J, K for this assignment.